Okay, guys, so let's start. So today we have to start with MGRE. Okay. MGRE. Now, so let me start the lab along with this. So today is about MGRE. Now, see, let's consider this is 10, 11. Okay, just 1 second. Leave one option. Fine. Let's consider this as a hub, and these are the three spokes we have. Okay. Connected like with this, and this is here. Consider this is 11.1, this is 15.1, about 16.1, and then 17.1. This is ISP. Okay, on this interface, like we have .10 IPs and all. So overall, what there should be reachability between these sites. We have to make sure what should be the reachability. So this is about headquarter, or this is, you can say, you're about hub. This is, we have spoke 1, or you can say your branch office 1 here. This is spoke 2. Okay, so this is spoke 2 here. And this is spoke 3. Okay, now we have to make sure there should be reachability. After the reachability, then we have to configure what? Tunnel interface. So let's start with the hub here. So in the hub, first of all, I'm going to configure one the tunnel interface 0. IP address is 192.160.1.1. So this is the IP address what I'm going to be use it here. Okay. So on this side, I'm going to be use 192.160.1.1. Here I'm going to be use what? Instead of this is not a P2P. Okay. .2, .3, and about .4. So how many like tunnel networks I'm going to be use? 1, because I'm talking about here MGRE, multiple GRE. So this is IP address here. After that, we have to mention the slash value. After this, the next concept I have to define here, tunnel source. Okay, what is the tunnel source? 11.1.1.1. So if you would define tunnel destination as a 15.1.1.1, so this means this concept is known as point to point here. So, but we do not have to define any destination. So what we have to define now, we have to define tunnel mode GRE multi. What we have to define here now, tunnel mode GRE multipass here. So this is the command to enable MGI. So this is, with the help of this, we are going to be enable MGI. Can you note it down? All these commands here. Okay, so this is on hub, and even it will remain same for the spoke also. Just note it down. Clear? So this is the same on the another side. We have to mention here. Now, again, here the thing would be interface tunnel 0. Okay. IP address 192.160.1.2. Tunnel sources 15.1. Tunnel destination, if I would define, so it would be what? Point to point, but I have to define tunnel mode JRE multi. Okay. So this is the concept. Let's consider. Behind this, again, we have a loopback here. I have a loopback, let's consider, which is about 1.1.1.1. And behind this spoke, we have a LAN, okay? And which network is your 2.2.2. Okay, so what is exactly the requirement, how I'm looking for? Okay, once the tunnel would be formed between them, okay, after that, I have to exchange the data via tunnel. I have to exchange the data via tunnel here. So let's consider I have configured interface tunnel here, IP defined, I have defined, tunnel source I have defined, same thing I have defined on the another side. I have not defined any destination because if I would define the destination, then it would become my point to point. So how the packets, so let's consider now I want to ping it. Okay, ping from this device, ping to the 2.2.2 as a source of 1.1.1.1 here. How would be the packets looks like? So obviously we have ICMP header and all. Okay, so this is source IP, destination IP, GRE, source IP and destination IP. This is ICMP, source IP, destination IP, GRE, and again source IP and destination. So this is all about, now just let me note it down here. Source IP, destination IP, GRE, again source IP, again destination IP, and this is ICMP. Okay. So if I talk about, so two times we have source IP and destination IP. This is once and this is another one. Because this is what? This is outer and outer header. And this is what? This is about inner header. So in ICMP, we would have ICMP data and all. So what would be the value in the source IP and destination IP in the inner header, guys? What will be the source IP? Online guys, kindly mention your answer in the chat box. What would be the source IP and destination IP now in the inner header?
11.1 or 15.1.
Okay, what about other guys? I'm waiting for your reply, guys. Only one guys has replied. What about other? Kindly mention your answer in the chat box. I'm waiting for the same. Yes, everybody, I'm just waiting for the answer. how it can be 11.1 and 50.1? It just would be 1.1.1 and 2.2. This is the reason you are not practicing. I'm talking about inner header. And what is my source and destination? I have pinged for like where? From I have pinged. This is my command here. So how it can be 15 and 11? That is always for the outside header. It means you guys are not practicing, just doing the classes. That's it. Now, so now what is there? What is, I have to define a source IP now. So what is my source IP? My source IP is just 11.1 here. From where it would pick the source IP? It would pick the source IP to the this one. Okay. What about the destination IP? Do we have any destination IP into this? No. So if you would try to if you would try to ping here, so my header is not completed. This is my GRE only. This is what? Just a GRE. So my header is not completed. So what kind of error we would get it on this particular router? Okay, that encapsulation failed. What is failed? Encapsulation. Here encapsulation means packet is not ready here. Something is missing. And so in that scenario, what is missing actually? Destination IP. Earlier, if I talk about then the point to point, in the point to point, what was the interface tunnel 0? And IP 192.168.1.1, tunnel source 11.1, and tunnel destination 15.1. So we used to define destination IP. Okay, that's the reason we never face this kind of issue. But now here we can first of all, what is missing? Destination IP. Okay, the question is okay, let's define the destination IP, tunnel destination. If I would define tunnel destination over here, so that would become what? Point to point here, and this is not a point to point here. Okay, so what is the solution for here? So now we have a protocol. That protocol name is NHRP, Next Hop Resolution Protocol. Note it down. This is like a ARP, Next Hop Resolution Protocol here. Okay, so how NHRP is going to be helping now? NHRP is like your ARP. ARP, what exactly ARP helps? ARP, like we have IP address and it would always help to find out MAC address there. So now in NHRP would help us what? We have the tunnel, like what I have mentioned here, 1.1 and 2.2.2 here. Okay, so where exactly this 2.2? So this thing manually we have to define here. Okay, so now we have to define one NHRP mapping here. What we have to define? NHRP mapping. By default, NHRP is disabled, so we have to make it enable here. Okay, so for what is the command to enable NHRP? NHRP network ID 10. It's in a range between 1 to some number is there. I'll show you. So what I have selected, NHRP ID is 10 here. So that must be same now on all the routers. Make sure. So with the help of this, we have enabled what? It means we have enabled here NHRP here. Enabled NHRP. Okay, this is kind of your like a ARP table. ARP table is ready here now. Okay, so then in this table, we have to do the entry manual. What entry we have to do it? Manual. And what kind of entry? Like NHRP map. Okay, 192.168.1.2. If you want to go to this tunnel here, okay, you should go via what? Via 15.1.1. Exact command I'll show you. Okay, what exactly the exact command for the same? This is a VPN, right? VPN.
Many of here also we should know where it has to go. So then we find the point.
Sorry.
Like in multiple point also we need to mention the route also where to go. Find the point also like that one also.
No, I'll come. Okay, so this is now mapping here. Okay, so next time what happened? So if you would generate the traffic like this, okay, if I'm just want to ping from 2.2 and 1.1 and all, okay, because see, first of all, this is my NHRP map table. I have done the entry. Entry is fine. Now let's consider what is next. Next, this is entry here. But as you know, first of all, the tunnel should be up here. Okay, the tunnel should be able to ping. Once you would define this command, and after that, once you would you define the same now on the hub side also, what we have to define NHRP map, sorry, NHRP network ID, and that is 10, and then NHRP mapping 192.160.1.1, and how to reach 11.1.1.1. Mapping I have done. Okay, so what happened now? As you know, let's talk about from this router here. It has a routing table. Let's consider this is the routing table of which device? Hub here. Because I do not have a space, so that's why I'll just mention. Okay, I'll mention it here. This is what? Routing table of what? Routing table of hub here. How the entries would be there. First of all, directly connected, which network 11.1.1.0/24, which interface, let's consider Z0. Then we have 1.1.0/24, how it's connected, loopback 0. Then we have one more directly connected, 192.168.1.0/24, which interface, tunnel interface 0. So this is the one thing, okay, but let's consider I have to ping, okay, I have to ping from where to where? I have to ping from 1.1 to 2.2. So always we need a routing table because this is a route base. So we have to define, let's consider if you're using an EIGRP, consider you are using static EIGRP or whatever. So let's consider the entry would be what? If you want to go to 2.2.0/24, you have to go via what? 192.160.1. Yes, 1.2. Because who's 1.2? Then this is next hop over tester. Because now, once over configured earlier commands here, the NHRP table and all, okay. After that, this would be what? This would be up here. This entry is ready or not? Now, question is next. Okay. The concept is if when you would try to ping, okay, so it would take like it would look into this routing table, okay, where is the destination? 2.2.2. Do we have any reachability with this? Answer is yes. How? Via 192.160.1. How to take the exit? We have to take the exit from the which interface? Telling interface 0. So you have to go via what? 192.160.1.2. But once you will after this, once you will go to the interface because you have to reach to the via this one. Okay, but for this, which is your exit point? Exit interface is this fine, but in the context of the public IP, who's your destination? That is missing. So for that, when you would enable your NHRP, okay, so then it would look into the NHRP table. It would look into the which table here? NHRP table here. So now this is what? This is my NHRP And in this table, there would be an entry. Entry would be how? Like how to reach to 192.168.1.1 via 15 dot. This is dot 2, sorry. In the upcoming after that, with the spoke to 192.160.1.3, we have to define the mapping, and this how would to reach. In the upcoming then 192.160.1.4, how to reach there 17 dot. Because without public IP, encapsulation is failed. In P2P, NHRP table was not needed. Why that was not needed? Because in the interface itself, we used to define destination. That problem was solved at that time itself. Okay. But this time the problem is because we have multiple kind of tunnels from here. Multiple what? We have multiple tunnels. So first of all, as a sender, you have to look into the routing table. You are going with via what? 192.160. This is your next stop. How to reach? Via tunnel interface. So then for this, what is missing? Destination IP. So based on this via, okay, then it would look into the NHRP table. How to reach? 15.1 and now 15.1 entry would be here. So this missing part, because 15.1 was missing, so now we have 15.1 input. Is this clear or not? Now packet is completed, it would be shared with the same concept on the another side, because mapping we have to do on the both the ends. Okay, so right now this is my NHRP table. How many like as per this like hub, okay, how many like spokes do we have? 3. How many entries are there? 3. But these entries you have to make it static. How static? Manually with the help of this command. Okay, so these entries are not going to be expired until and unless you want delete it manually. Okay, so this entry is what? Manual or not? Okay, so in the DM VPN, guys, up to here, everything will remain same. What is the only difference? You remember yesterday we have discussed static is MGRE, dynamic is DM VPN. So DM VPN is based on just how my NHRP table would be updated. If it's getting updated like update while like manually, that concept is known as MGRE. And if it's happening dynamically with the help of NHRP only, that concept is known as DM VPN. ARP table. You always learn till now that ARP happened automatically. There is a no MAC address. So that is dynamic ARP here. But we do have concept about static ARP as well. Static ARP means if this is my ARP table, we have to update it manually here. So that concept is known as static. So same NHRP. So if NHRP table is getting updated manually, so this concept is known as MGRE. And if it's dynamically, this concept is known as DM VPN. Okay, so up to here, all the commands would remain same. Only where is the difference? This portion, because this is the static. Next time it would be dynamic. Make a note. Anything? This commands, I hope you have mentioned it, right? And this is about the NHRP table. Routing table we already discussed previously. So now I'll start with the practical. Okay. So let's start with this. So I'm going to be mentioning here all the public IPs instead of the 10 and all. So this is about 11.1. This is 12.1.1.1. This is about 13.1.1.1. And then we have okay. These IPs, our tunnel IPs are going to be remain same. 11.2. This is about 12.1.1.2. 30.1.1.2. And this is about 14. Okay. I'm going to be use what? MGR. Okay. So as an overlay protocol, underlay protocol, I'm going to be use here default routes. What I'm going to be use default. An overlay protocol we would use as a EIGRP. Okay. So here overlay we would use as a GRE. Overlay we will use as EIGRP. Okay. As a 10. And if you talk about an underlay, we would use just a default. Okay. So this is ID. This is side B. It's all about spokesmen, right? Now, so one more thing is missing here, which is about the loopback. Right, on all the devices. One is loopback 0, 1.1.1.1. So this is on loopback 0. This is on this side. This is here as a like a 2.2.2.2. This is as a 3.3.3 here. And this is again 4.4.4.4. 192, what is this exactly? This is all about tunnel. Okay. So this is tunnel 0. The same here. Tunnel 0 I can define, or I can define a 1 as well here. Okay. Interface 1. Tunnel interface 2. And this is here. Tunnel interface 3. Already now? All set? Okay. And this is this one. Any doubt, any questions, anyone? I hope all clear, right? Okay. So now let's start it. Okay. So I'll just now I'm going to be write it on the notepad. It would be easy for us to edit it. So first of all, the host name is as a hub. Okay. Now, interface 0/0, IP address is 11.1.1.1/24. No shit. After that, interface loopback 0, IP address is 1. Loopback is what? 1.1.1. This is 0. Okay. IP route. Next stop is 11.2 and about 2. Right. Tunnel interface we will define like ourselves. Okay. So this is this. So this is now about spoke 1. Spoke 1 here. 0 interface, which is what is the IP? 12.1. So this is about 2.2.2.2. And this should be 12.1.1.2. Next stop is fine. This is spoke 2 now, all about 13.1. It's now 3.3.3.3, and this is as a 13.2.
So what is the do right?
Sorry,
Do right.
do right. You don't know do right? Seriously? You're sitting in CSI class and you're asking what is do right command? You have not used, is it? You should focus on your practicals. If you never use right command, seriously. Okay, this is clear. Okay. Now copy and let me paste into where this is about hub here. I have pasted on the hub. All clear. Second command is this is spoke 1. I use 3 spoke 1 here. This is spoke 1. As 4, 5. This is 4, spoke 2. And all clear. Only which one is pending? ISP. Okay. So let's come back here. This is about ISP. And 0/0 interface, which is about 11.1.1.11.1.2. Okay. Now 0/0. So now 0/1. It should be 12.2. 0/2 now. It should be 13. And this is 0/3. It should be 14. Okay. All good. And now copy and paste it on the ISP. So now onwards, we have to make sure there should be reachability, and we have to verify the reachability from where. I can just define, like I can verify from the hub here. Okay. Ping with what? 12.1.1.1.1. That's fine. Next is ping with 13.1. Next is ping with 14.1. I have reachability. Clear? Okay, from hub, if I can ping with my all the spokes. So this is now we have reachability everywhere. So if you want to verify still, you can go to any one spoke. Let's consider this is spoke 1, and I have decided let's ping with 13.1.1.1. Next is 14.1, and then 11.1. Okay, so shall I start with the configuration of the tunnel? Okay, because now everything has been configured. We have all the reachability. Now let's get into where? Get into the tunnel interface. Now, interface tunnel 0, IP address. Okay, I'll just show you one thing here. IP address. Okay, IP address has a 192.160.1.1/. 24. Tunnel source is what? 11.1.1. No, all clear. Okay. Do show IP interface, please. This is fine. Okay. But its protocol would show us what? Down here. The reason because we have not defined any destination. So if I would define tunnel destination 15.1.1.1, tunnel would be up now. And on my spoke 1, if I would define all this thing, interface tunnel 0 IP address 192.168.2/24, tunnel source 15.1.1.1, tunnel destination 11.1.1.1. I have configured point to point. Okay. So IP interface brief here. Okay, I have did one mistake here. Interface tunnel 0, tunnel source 15.1.1.1 I have defined. Even tunnel destination is what? 12.1.1.1. And here also one small mistake. Destination I have defined this one. Then tunnel destination is 12.1.1.
And also it's a tunnel 1, not tunnel 0.
Show the, I'll do one. No interface tunnel 0. Okay, interface tunnel 0. Again, IP address 192.168.1.2/24. Who's the tunnel source? 12.1.1.1. And whose tunnel destination? 11.1. Okay, so same here. No interface tunnel 0. Interface tunnel 0. IP address 192.168.1.1/24. Tunnel sources 11.1.1.1. Tunnel destination is 12.1. All clear? So from my hub, if I would try to configure, also if I'll try to ping with 2.2. Sorry. If I'll try to ping with 192. This is tunnel interface as a source of what? 192.161. So tunnel interface to tunnel, am I able to ping or not? Clear or not? Mention this thing. And just in point to point, the case 1, just mention it a case 1. Okay. As a point to point GRE tunnel. Okay. Point to point GRE tunnel here. So we are able to ping between the tunnel interfaces now. We are able to ping tunnel between the tunnel interfaces of any two sides you can serve between the hub and spoke. You can see, right? I'm able to ping here. All clear, all fine. Next concept is if I'll configure EIGRP, router EIGRP 10, network is what? 192.168.1.0 wildcard mask. If I would define this, I have defined on hub. And now if I'll go to the spoke 1, this is also. Neighborship is up or not? Show IP, EIGRP, neighbor. Neighborship with the queue count is 0. So note on second point in the same case, now EIGRP configuration is up. After the EIGRP configuration, now EIGRP neighborship is what? Up here. So after this, so I can advertise any kind of network from the EIGRP because neighborship is up, and I can advertise loopback 2.2 and 1.1, and after that they would be able to ping. Correct or not? Online guys, any doubt, any question into this? I hope clear. It's clear.
Sir, one doubt, sir. What will that no auto command will do?
This is not a routing switching class. Kindly go through your like this EIGRP now. Okay. Clear? This is clear. So now, any doubt in MGRE, in GRE concept? Because these are the routing and switching concepts. So kindly go through this. One student is asking what is write command. So this is not the time for that. Okay. I hope this is clear. Now, so any other students, any doubt, any questions in MGRE? All clear? Sorry, in GRE, this concept here. Now what I'll do it here, I'll just remove both the process. Both the process means no router EIGRP 10, no interface tunnel 0. I have removed from hub, and here also I have. All clear? So now we have seen here, like my tunnel interfaces are up, I'm able to ping, and after that I have configured EIGRP, and neighborship is what? Up here. All clear? Now, next concept is here. Let's start with the MGRE. What is that? MGRE. So as per MGRE, interface tunnel 0, just look at the screen. Okay, commands are simple. I'll give you the commands. Interface tunnel 0, IP address 192.168.1.1. IP address configure. Tunnel source 11.1.1.1. Tunnel destination I cannot define because this is not a P2P. I have to define its mode GRE multi-port. Okay, up to here it's clear. Okay, so the same command I'll configure on the spoke now. Spoke 1 right now. Interface tunnel 0. Okay, not tunnel 0. Let's consider no interface tunnel 0. Now interface tunnel 1 we have decided here. Okay, so what is IP address? 192.168.1.3. Okay, I'll make it 2. I'll make it what?
That time you had given 1.2 in that.
Yes, 2 is missing, yes.
Okay, fine. So this is what? .2. So what I'll do it? This is, I'll define it as earlier is that this is 2. Because then it would be in a sequence, okay? It would be easy for us. I'll make it as it. Okay. This is clear. Now define a tunnel source. Who's the tunnel source? 12.1.1.1. As you know, tunnel destination we cannot define because I'm using MGRE. So I have defined its mode GRE multi. Up to here, I hope it's clear to everyone. Okay.
Yes.
This is the same commands which we have discussed over. Okay. So if I would talk about on hub, and this is about on spoke here. Okay, spoke 1 right now, but commands will remain same. So interface tunnel 0, IP address 192.168.1.1/24. Tunnel sources 11.1.1.1. Now tunnel mode GRE multi. Up to here it's clear. And same on the another side, just different IPs. This is just a .2, and this is I have defined .1, and this is 12.1 mode G. Now I'm using multi-point, okay, because I have defined MGRE here. So immediately now I need to define what? NHRP, because what would be needed here? NHRP. So the command is IP NHRP network ID. It's in a wide range. You can use anything over here. I'm going to be use 10, but now make sure that must be same on all the devices. I have defined NHRP this one. Same command I'll copy and paste it on the another side because that must be same. So that's the reason I had did it. If I'll define it here. Any doubt in any single command even? I hope all clear. Now, next is we have to do the mapping. What we have to do it? Mapping here. Let's consider right now we have not done any mapping here. Okay. IP debug 192. Right now, my tunnel interfaces are still. I'll show you the tunnel. This is on hub. Show IP interface. Brave. Tunnel interface is up or not? It's up. On the spoke side also, if you would check it out, show IP interface. Brave. Tunnel interface is up or not? Last time when the tunnel interfaces were up in the P2P, we were able to ping. Now just ping 192.162.1.2 as a source of 192.162.1.2. Even tunnel interfaces are up, okay, but still we are not able to ping. The reason, because outer header is not getting complete. And what is the error we are getting? Encapsulation failed. Okay, why it's not getting complete here? Because in P2P we have seen, okay, if I'll talk about here P2P configuration, in P2P we have always interface tunnel 0, IP address 192.168.1.1, tunnel sources consider 11.1, and tunnel destination was 12.1 and exit. So when we were doing ping, when I was pinging, so what was happening? The source IP, destination IP, GRE, source IP, and destination IP. So the source IP and destination IP, this is the ping between the source IP, destination IP, and this is all about GRE. So what is the source IP into that? 192.162.1.1 and 192.162.1.1. Because this is the ping. Right now the same I have pinged it or not. If you would check it here, what I have done, the same ping. This is the command for the same. Clear? So right now, actually in P2P, okay, the source is from where? The source is 11.1 and destination is what? 12.1. That we have defined manually where? We have defined manually in the commands itself. This is source and destination. But here only what is defined? Tunnel source. But what is missing right now? Tunnel destination is missing over. So means which part is missing? This part. So that's the reason which error we are getting. Encapsulation error. So in MGRE or in DMVPN, in case if you are getting any encapsulation error, so it means your outer header outer header is not completed. Okay. So what is missing now? Mapping is missing. What is missing here? Mapping. So I have to do a mapping here. So I'll just be back on hub and I'll just type here interface tunnel 0 IP NHRP map. IP NHRP map here. Mapping is about 192.160.1.2 because I'm on hub 1 and I have to go to where? Hub 2, which is what? 192 spoke 1. So 192.160.1.2 and how to reach? Clear or not? Okay. So show IP NHRP. This is the table. Okay. And now you can see you can go to what? This tunnel interface via what? So via 12.1.1.1 NBME, non-broadcast multiple access. Entry is about never expire. Tomorrow there would be timer for that. That is 2 hours, which is the DMVPN dynamic entry. Dynamic entry has always a timer. So this is what? Never expire. Okay. So this is just where on the hub side, if I'll go back on the spoke and if I'll enable debug IP packet, let's try to ping again. So from here, we are sending it. Now encapsulation is not failed, but on the another side, encapsulation is getting failed. The reason, because on the another side, we have not done any mapping. Because another side, what is missing again? Here, I have done the mapping. What is that mapping here? IP NHRP map 192.160.1.2. How? 12.1.1.1. So here packet is getting what? completed, which is now how to reach via 12.1. But on the another side, there is a no mapping. Because, okay, so that's the reason now encapsulation failed error we are getting on the which side? On the. Is this clear? So what is the solution? The solution is, let's go back to the spoke and interface tunnel 1 to show IP interface. Let me just verify the tunnel interface, 1 only. Now, IP and HRP map, whose hub 192.162.1.1, how to reach 11.1.1. To show IP and HRP. This is also updated, and now just try to ping. I'm able to.
Like same mapping spoke 2 and spoke 3, sir.
Yeah, same thing. Then, because this is just for the one. So what is the disadvantage of the MGRE? If you have multiple branches, multiple entries are required as a manual. Manual would be needed. Like static entry. Let's consider you're working in one big network, and instead of dynamic protocols, routing protocols, you're using static. Static is what? Manual entries here. Okay. But what is the dynamic? AHRP, OSPF. Okay. So this is the same concept. So now you can see from hub, I'm able to. And from spoke also, if I'll be go back ping to 192.161.1 as a source of, on the both the sides we are able to. So just, okay. So we have solved the problem of multiple P2P concepts here. Okay, point-to-point tunnels. But one disadvantage is there. This NHRP table, which is on all the routers, we have to update every time. So if you have 200 branches, and after that you are adding one new branch there, which is 201, okay, then about this new branch, you have to update all the 200 routers, and along with that, on this router, you have to make another how many entries? 200 entries. So 200 is this and 200 is this. So almost how many entries? 400 entries. Now you would realize once we started further. Up to it's clear. So now what I have done here, so I have done the mapping again here. So this side, this time the mapping is towards hub, IP and HRP map 192.162.1.1 as a 11.1.1. Clear? Make a note. Just try to understand the commands here. Multiple commands we have. Tomorrow even further we have, like in the same commands we have to add. Instead of this manual mapping, we have to remove this command, and then again further 4 or 5 more commands would be added. Okay. So just try to understand the meaning of the commands here. GRE, MGRE is very important from interview perspective.
Sir,
Yes, please.
whether we use this NHRP or all those things currently in the industry?
Yeah, we use NHRP if we are using DM VPN. Okay, so definitely we have an option of NHRP.
Since we can nowadays people will configure this IPsec tunnel or SSL tunnel in the firewall itself.
Right. See, IPsec is different concept. IPsec is different. MGRE concept is different. Okay, that is the policy-based VPN. This is route-based VPN. Okay.
Got it.
So we have both the concepts in this. So it has its own advantage and disadvantage. Okay. That has its own, like you can say, do and don'ts kind of stuff. Okay. Yes. Any other students? Any doubt? Any questions? Anyone? Especially online guys. Any doubt? Any questions? All clear? Everyone? Because then DM VPN is totally dependent on this. That is non-broadcast multiple access. You have not gone through your routing concepts, Santosh?
I have, sir.
So this is the same. NBMA which we use in EIGRP and OSPF, non-broadcast multiple access. Especially we use in OSPF. Okay.
Any branch office critical application we are communicating with the headquarters. In that case, we can use these VPNs.
Yes, you can. Multiple scenarios are there. Okay. Now, after DMVPN, the things again would be more clear. Okay. Because this is static concept here. Instead of static, we use dynamic in the corporate, which is DMVPN. And DMVPN has how many phases? 3. So what exactly, if let's consider between spoke to spoke, you want to enable any communication, but you want ki whatever they are communicating, that should happen via hub. I want to, on a hub, I want to monitor it. So instead of directly exchanging the data between the spokes, okay, they are exchanging the how via this one. This is request and this is reply of that data here. So those are the scenarios what you want in your corporate. And sometimes, okay, no, I do not want this because this is too hectic for me. So I just want what? Spoke to spoke direct communications. So that depends again on phase season. Okay. Now, so it means right now, guys, I'm able to ping between both the tunnel interfaces. I can configure EIGRP. Just try to go through your previous ones. I have asked you, like in the case one, I hope you have mentioned, right? In the point to point, there was a concept that we are able to ping between the tunnel interfaces, and after that we have configured EIGRP, and EIGRP neighborship was up here. So now let's try to configure that. And right now, again, you can see I'm able to ping. So it means if I'll configure EIGRP neighborship should be up, let's do that. Now, router EIGRP 10, network 192.168.1.0, wildcard map. No, okay. This is here. And then on the another side, copy and let me paste on the hub is fine. Now on the spoke side. Configure. Now neighborship should be up. So just wait. Show IP EIGRP neighbor. Even if you would check, you can check it out here. I'm able to ping with 192.168.1.1. Source as I'm trying to ping from the spoke 2 now. I'm able to ping, right? Spoke to hub, and now if you would check it, I'm able to ping. So show IP EIGRP neighborship. Earlier it was up. Now the problem is key show IP EIGRP neighborship. Sorry, show IP NHRP. This is entry about the unicast traffic. This is for what? Unicast. Like a same, we have to do it for the multicast. Okay, this is for what? Unicast only. Okay, so we have to do the same concept for the multicast traffic. Okay, what is we are getting the error? Encapsulation failed. Because now both the sides, they are just want to exchange what? EIGRP hello messages. Source IP would be 192.160.1.1. What would be the destination IP in the hello message? 224.0.0.10 here. But what is happening? Encapsulation is getting failed. Because this mapping is just applicable for the which traffic? Unicast traffic, not for the multicast. So the same problem what I was facing earlier before the ping. Okay, same I'm facing for the what? I'm facing on the EIGRP. So I have to enable mapping for the which traffic? Multicast traffic here. And what is the command for that? The command is simple again. I'll go to the hub. This is the hub now. Interface channel 0. IP NHRP mapping for multicast. And 1 second, multicast, then. Multicast with the same 11.1 will be there. What will be there? That would be 11.1. So this is the manual mapping here. Okay. Here and then multicast, I think that command I have not mentioned here. This is just a manual mapping. Okay. No problem. So just let's go back here. Here, multicast. And now who's my NBMA? I want to exchange with 12.1.1.1. Okay, so show IP and HRP. Okay, but it won't show you this entry. Clear? But this is enabled for the multicast also. So now from here, debug IP packet. Okay, from one side it's sending. On the another side, you can see here, show IP HRP neighborship up. But what is the queue count? 1. Okay, debug IP packet. Because the encapsulation has been succeed on the one side. Okay, but from the another side, still is what encapsulation. Because we have not enabled mapping for the which traffic? Multicast traffic on the spoke. So that's the reason. Now, I hope this is clear. We are getting the errors. This one packets here. I'll disable it. And now, show IP HRP neighborship. So one side we have exchanged, but another side is not completed. So now what we have to do? Spoke 1, interface tunnel 1 here. Then IP and HRP mapping for which traffic? Multicast 11.1.1.1. Done. And now neighborship would be show IP interface. Sorry, show IP HRP. Queue count is what? Done. Neighborship is. And now what you want to advertise? I want to advertise from here loopback 1. From the hub, I want to advertise which one? Loopback router HRP 10 network 1.1.1.0 wildcat mask. If I'll go to the spoke 1 and if I'll check their route, show IP route HRP. I got the information. Okay. And now from here we need to advertise. Okay. And now ping with 1.1.1.1 as a source of. Perfect. We are able to exchange. So this is my hub and you can start a capture into this. So just you have to understand what is the meaning of the commands here. After that, everything would be simple. Still, if you're struggling with the commands, okay, then it would be difficult. MHRP, this is about NHRP map. For earlier, it was it was for 192, that was the multicast. So this is for that was unicast, and this is for multicast. Okay, so this is, and now this is for the. That's it. And this is the final command. That's it. So just you have to get into the spoke 2, add the commands related to the hub 1. Okay. And if you want to enable any communication about spoke 1, then enable the spoke 1. So one by one, we'll do it now. So you can see these are the messages here. Okay. And if I'll be back. And if I'll try to ping, this is a ping. Okay. This is about now. And if you would check it. Okay, sorry. ping width 2.2.2.2, source of 1.1.2. Show IP HGRP, show IP route HGRP. 2.2 via tunnel interface. Okay, and if you would check the captures here, what happened? Why it's same GRE header, everything will remain same. Okay. Even if you can check it out, this is also checked. Clear? Same inner header, this is outer. Inner header this time 224. This is for the AGRP, but these are the updates packets. Okay, and this is the outer headers 11.1 and 12.1. So I hope this is clear. ICMP echo 1.1, 2.2, 11.10, 12. All clear? Same. Now get into the spoke 2. On the spoke 2, just see configuration. So it's clear. I hope now. Just you have to look into this. What exactly I'm going to do here now. Interface tunnel interface 2. I have decided. Interface tunnel 2. IP address 192.168.1.3. Tunnel source would be 13.1.1.1. Destination I cannot define because it would be P2P. So tunnel mode GRE multi. If multi-point, so first of all I need NHRP network ID, IP NHRP network ID 10. Then mapping IP NHRP map about whom 192.160.1.1. How to reach? This is the entry about whom hub. How to reach to spoke 2? Who's my spoke 2? Dot 2 here. How to reach? Clear or not? Same concept or not, like hub? Okay, so in future, this would be my tunnel 3. So now only I'll do the entry for that. What is the IP of my tunnel 3? Dot 3. How to reach? So how many commands I have used? 3 commands. 1 for hub, 1 for spoke 1, 1 for spoke 3. This is just for unicast traffic. Now same for the multicast. Okay, so IP and HRP map for multicast. One is 11.1.1.1 hub, spoke 1, spoke 3. My commands are ready. All proper good. I'll be back on hub 1 because on hub 1 I have not entered anything about this one, right? So now what is needed here? 2 commands. Interface tunnel 0. One is mapping for the unicast traffic. How to reach 192.168.1.3, 13.1.1.
Sir, you mentioned that 1.4, 1.3, sir, instead of 1.4, that for reaching 14.1.
Yes, sir.
Sorry, where?
Same.
Mapping, sir.
On which
NHRP
device?
mapping.
On which device are talking about?
Spoke tunnel 2, sir.
To run interface tunnel 0. Sorry. To run.
You mentioned 192.168.4 should be 4, but you mentioned .3.
No problem.
This mapping, it's 1.4, sir. That
Where 1.4?
192.168, 1.4 should be.
Okay,
map-
this is I have, okay. Okay, I have mentioned for 1, 2, okay, this one I have defined, right?
That one.
Turn interface 0, no, just remove the command. Okay, and now instead of 1.3, 1.4 as a 14.1.1. Right now? Now. So this is the mapping for the spoke 2 for the unicast, and now for the multicast. MHRP map multicast with WOM 13.1.1.1. Okay, so can I ping with 192.160.1.3 as a source of 192.160.1.1? I'm able to ping. But what about EHRP? Show IP EHRP neighbor. Is this neighborship up with that? No. The reason, because on spoke 2 I have not defined EHRP. So the outer EHRP 10 network 192.168.1.0 wildcard. Neighborship is up. Show IP neighborship with Q count 0. But on the hub, how many spokes we have till now? 2. Spoke 1 and spoke 2. Show IP HRP with the Q count. That's it. Just from tunnel 2. Okay. Interface tunnel, sorry. Router HRP 10. Network 3.0.3.0. Wildcard. So on the hub 1, show IP route HRP. We have 3 information also. And on hub spoke 2, show IP HRP, show IP HRP, show IP route HRP. We have 1 information. If I would try to ping with 1.1.1.1 as a source of loopback of spoke 2 to hub 1 here, I'm able to ping. But along with this, I just want to ping with the spoke 2 as well. Do I have a neighborship? If this is my neighborship is up with spoke 2 or not? Show IP HRP. Not yet. The reason, because I have not mentioned the mapping of multicast traffic of spoke 1. You can see here I have mentioned it, okay, but I have not mentioned where on spoke 1. So I have to go back to spoke 1. So IP HRP neighborship. Can you see it's showing with the Q count 1? There I have mentioned it, but if you can check it out, NHRP, have I mentioned for it for the spoke 2? No, I have not mentioned it, which is for the multicast. Okay, not even for the unicast. So this mapping is needed over here. So interface tunnel 1, IP address, sorry, IP NHRP mapping about unicast traffic. First of all, 192.160.1.3, how to reach 13.1, and next is IP NHRP mapping for which one? Multicast, how to reach. Done or not? So this is one of the show IP HRP neighbor. Q count 0. Show IP HRP. Show IP route HRP. I have 3 information or not. Who's 3? Spoke 2. And if you would try to ping with 3.3.3.3, the source as a 2.2.2, I'm able to ping or not? The one disadvantage is there that every time multiple entries are needed. Let's consider now I'm adding spoke 3. Have you configured anything on this one about spoke 3? Till now I have not configured. Same I have on this, so I have configured, but on spoke 1 and hub I haven't configured. This is just a small topologies, okay? But let's consider if you have 200 sites, every time if you are adding a new spoke into that, so multicast and the unicast traffic need to be mapped in all the spokes there along with hub. So this is the disadvantage. So tomorrow, once we'll start with the DM VPN, this mapping would happen automatically, the dynamically actually. Okay, so for this, I'll be back now to my spoke number 3. So I'll do the entries for all here. For all means what? 2 spokes and 1 hub. Interface tunnel 3. IP address 192.168.1.4/24. Tunnel source 14.1.1.1. Tunnel mode GRE multi-point. IP and HRP network ID 10. Enable now mapping. Map. First unicast traffic with all the devices. First of all, let's go to the spoke. So who is my spoke? 192.160.1.1. How to reach? 11.1. This is hub, sorry. Now spoke, who's my spoke 1? 192. How to reach? 12.1. Now spoke 2, who's that? 193. How to reach? So this is for the unicast. Now for multicast. IP and HRP map multicast. As per multicast now, first of all, 11.1.1.1. Hub 12.1. Spoke 1. Spoke 2. All done. Router HRP 10. Network 192.160.1 dot. What is 1.0? Wildcard mask. Noto summary. Network. I have a loopback. I'll advertise in the starting. So show IP HRP 1.3 is showing with a queue count 1. So in some time the queue count would be 0. So now along with this, what we have to do it, I'll be back on my hub here and I have to do the entry for WOM spoke 3 here. So what I have to do it, interface tunnel 0. I have to do the entry here, IP and HRP map. First of all, for the unicast, 192.168.1.4. How to reach? 14.1.1. Next, NHRP map multicast. How to reach? Same commands. I have to copy and I have to paste where? On my spoke 1. Where I have to do it? Interface tunnel 1. IP and HRP map 192, sorry. Multicast 14.1. That's it. Okay. And I think on this side we have already defined it. So IP HRP neighbor. Who's my neighbor? Dot 1 is neighbor, dot 2 is neighbor. So run section NHRP. I think I haven't configured here the multicast topic. Multicast 11.1, 12.1, 14.1 is fine. 192.1.4, how to reach 14.1. That's absolutely fine. Show IP HRP neighbor. Queue count is showing. Okay. Go to hub. Show IP HRP neighbor. So who's the neighbor? 3 neighbors. Who's that? 1.2. Who's 1.2? Spoke 1, spoke 2, spoke 3 here. With queue count 0. Show IP route HRP. I have 3 network information. 2 is from spoke 1, 3 is from spoke 2, 4 is from spoke 1. So we are facing the problem where if I'll be back here and if I would check it, show IP HRP neighbor with 1.3. I'm getting the issue with this one. Okay. So what I'll go back here. I think what mistake I have done. Tunnel 4, show IP interface brief. 2 tunnels. I have a habit now like of tunnel interface 0, 0, 0. So that's the reason. So what I have to do it, interface no interface tunnel 0. 0 is not there. Only which tunnel we have? Tunnel 2. And now check it. Show run. Show IP HRP neighbor. This is still showing. This one here. Show run section NHRP. Now we would check it. So 1.4, 1, 2, 3 entries there, but do we have about 1.4? No. Okay. And 14.4, this is also fine. Interface tunnel 2. IP NHRP mapping about 192.160.1.4. How to reach 14.1.1.1. And multicast is already built. To IP HRP neighbor. And now you can see queue count is 6. So show IP HRP, show IP route HRP. Clear or not? Okay. So this is, if along with this, if I have to do one more entry, let's consider I just want to add one more spoke here with 15.1 as a 192.1.5 here. So first of all, here I have to do the entry about my hub, spoke 1, spoke 2, spoke 3. Here I have to do the entry about spoke 1, 2, 3, spoke 4, spoke 4, spoke 4, and spoke 4. So 2 commands are needed here, one for unicast, one for multi, uni, multi, and uni-multi. Same here, 2 for unicast, 2 for multicast. This is here, 2 here, 2 here. And so how many commands are needed here overall? 2, 4, 8 commands here, 10, 12, 14, 16, and then some more commands. So approximately 20 plus commands are needed. And you have to log in on each and every device also. On a single device, if you're doing it, that's okay. Somehow we can understand. But how many times you have to, like, of how many devices you need a remote access, of how many devices we needed? 1, 2, 3, 4 devices. Because only new spoke is not going to help me. I have to do the configuration on the other devices. So if you want to add a new spoke in your bigger network of 200 spokes, okay, so it means you have to log in into how many spokes? Again, all the spokes. So that is the time taking process. So but right now you can see from here, from the spoke 1, if I would try to ping with 2.2.2.2 as a source of 1.1.1, spoke 1, now ping with 3.3.3.3. Which one? Spoke 2, and who's 4.4.4? And if I'll go back here, if I'll check the captures, these are all the captures, and we have what? GRE. So now just, it would take only 2 minutes. Let's configure what? IPsec on top of this. Okay. Crypto as a CAM policy. As a CAM policy 10. Encryption 3-, hashing MD5, group 2, authentication, operation. Crypto as a CAM key, Cisco address with multi. Multi means because now how many spokes are going to be configured or this IPsec on top of this? Multiple one have. So that's the reason what I have mentioned here, 0.0.0 here. Crypto IPsec transform set. Name is T set here, ESP 3-, ESP 3-, ESP MD5. Transport mode only I'll use it, or else you can tunnel mode only I'll use it, or else you can use the transport. Then crypto IPsec profile. The name is IPsec set transform set. What is the name? T set here. Interface tunnel zeros. Okay. So now I have to make it what? Interface tunnel 0. Then tunnel protection with which profile? IPsec profile name is what? IPsec. Clear or not? Just on every spoke, you have to change its tunnel interface. So this is for my hub 1, because I have different tunnel interfaces. I hope all the comments are perfect as a campus. Okay. Why this is 2 times? Now, interface tunnel is what? 1 now. Okay. 1 is for which one? Spoke 1. All is clear. Now, interface tunnel 2. Now we have tunnel protection with IPsec profile. The name is IPsec. So this is for 2, and tunnel 2 is on where? On spoke. This is my spoke 2 now. All clear. As a camp is on. The last is where? Last is on tunnel interface 3. Okay, so just wait and watch, and just wait here, because multiple times this, okay, what would happen here? Let's you just can wait for some time. The neighborships are getting up or not. Show IPJRP neighbor here. Its queue count as what? All perfect. In case if your neighborships are not coming up and you are sure everything is perfect, so just do one thing. All the tunnel interfaces, make them once shut and then no shut. Okay. Show IP, AJRP, neighbor. All queue count are okay, perfect. Show IP, AJRP, neighbor. All queue count perfect. Show IP, AJRP. Perfect. So now from my hub, I can ping with 3.3.3 as first. Let's ping with 2.2.2.2 source as a. If you would check it, please. What is that? Handshake is already done, and this is what. Clear? This is known as IPsec. So today we have completed MGRE, and along with that, IPsec over MGRE. So MGRE is the combination of what? Your GRE knowledge. Here your GRE and IPsec knowledge is required. Tomorrow in DMVPN, what would be needed? That you have to be very clear about GRE. What exactly GRE? You have to be very good into your MGRE also. And in MGRE, we have main concept about NHRP. You have to be sure about that. And after that, IPsec. So tomorrow the concept will remain same. There won't be any new concept. Today it was a new concept. Tomorrow again, concept will remain same. Just instead of the manual configuration, we have to go with what? We have to go with the dynamic. Clear or not? I'm done for the day. Online guys, any doubt, any questions, anyone? Yes, guys, online guys, any doubt, any questions? Anyone?
Here we are not removing that headers like GRE header, and yesterday we discussed. No,
If
those
you
not.
want, no, if you want to do it, just use which mode here? Transport mode, and along with that, deploy what?
SV.
SVTI.
Yeah.
And if you want to check it out, all these things, so for that, make it what? AH. Okay. So on top of this, so the same concept you can deploy, right? Which we have discussed earlier. So tomorrow again, same thing would be on top of as a DMVPN. Okay.
Thank you.
Thank you. Yes. Any other guys? Any questions? Any doubt? Anyone? Santosh and other guys?
Yes, sir. One doubt I have, sir. I'm slightly confused. You told that based on the company requirement, we can allow spoke to spoke communication, if or else if spoke to spoke communication has to happen, it has to go through via the hub. So if it has to go through via hub for spoke to spoke communication, what will be the NHRP mapping, sir? One example can you give, sir?
That we will discuss tomorrow, because today I have just discussed about MGRE. So that is the part of DMVPN, and once I'll start the DMVPN, then only we will talk about these concepts.
Okay, sir.
But
Okay.
right now you are not aware about DMVPN. Might be you knows, but from my side, so you don't know. Okay, so then it means first I have to explain DMVPN, and then I have to explain all this concept. Okay, so just wait till tomorrow.
Okay, sir.
Okay.
And one more thing, sir.
Yeah.
Yesterday we deployed GRE using IPsec, right? So in that earlier we used this command, sir, set peer.
Yes.
And in yesterday we did not use that command. So in previous class you told that it is required because we need to
In route-based VPN, your tunnel is already established.
Yes.
That is, are you using GRE or not? And GRE you have mentioned source or destination or not? So what is the meaning of destination? Means peer.
Yes, sir. Got it.
Correct? Because you are using which one? You are using route-based this time. You're not using a policy-based. In policy-based, you have to define the peer, because there we are not using any tunnel interfaces. But here we are using tunnel. So tunnel is already established. On top of that, you are using IPsec. So there, peer is not needed.
Got it, sir.
Got it? Okay. Clear? Any other doubt, any questions, anyone? All clear? So shall I close the meeting? Okay, fine. Then guys, see you tomorrow. Okay, so don't miss your tomorrow's lecture, which is gonna be very important. Okay. Okay, thank you guys. Thank you so much.
Okay, sir. Thank you, sir.
Now DMVPN would take 2 days. Okay, tomorrow and day after tomorrow. Bye-bye.
Bye, sir.